Okay, so welcome to Data Structures 2168. Let's see. Yep, got all my lights. Just I'm very in shadow today, apparently. Okay, so so here's what we're going to do today. We are going to briefly cover the syllabus, and when I say briefly, it'll probably take a half an hour, and then I'll go over the first assignment. And the hope by the end of the day is that you will be set up to work on the first assignment in lab. Okay. Lab, your schedule is basically as follows. Monday, Wednesday are your lectures. Lab is Tuesday. So for majority of your of the semester, a lot of heavy work is going to be done on Monday, Tuesday, Wednesday, and then hopefully you are going to be mostly clear for the rest of the week, if or only have a minor amount of work because of the way this class is structured. And I will explain that now once I go ahead and start sharing my screen. So, all right, so let's go ahead. So, all right, as you well know, by the fact that you're online with me as opposed to in a room at Temple, is that we are online for the first 2 weeks. Okay, as you are also pessimistically aware, there is a possibility if the school goes, and basically says, all online classes now, you know, which I'm sure a bunch of you are sick of at this point. However, I can assure you that in this that if that condition happens, you are in the right class. This class is designed that I can teach it in person, synchronously online, asynchronously online, and even if like some people are in person and not in person, I have designed this class for pretty much any modality. This class I am proud of, very proud of. I am very proud of the way I have put it together. So I really hope that basically, despite any kind of difficulties that you have, that this class will be a satisfying experience for you. So yes, the first couple of weeks will be chaotic. Keep that in mind. But if the chaos gets too much, just send me an email and I'll be happy to explain or help you with anything. Course details. Okay, so we are going to be going over a lot of different topics, some of which you may have already covered. Like if you've taken 1068 with Fiore, Professor Fiore, then you will have done array lists at some point, and you might have covered time complexity. We plan on going into detail on these topics in a bit more detail. You may not have covered generics, that's fine. A lot of these topics, if you haven't experienced it before, I will assume that it is the first time you are encountering it. Okay. Oh, let me open my chat window. So I'll get into that, but I will get into that in a second. So time and place. This lecture meets basically, we have 4 sections, and I have 2 lectures of this per day, which is why this class is flipped. Okay. So this class that's part of the reason the class is flipped. It's flipped, meaning that you will typically watch pre-recorded lectures each week outside of class and do what's traditionally considered homework in your lecture period. So each week, here's what you're going to do. You're going to go here. You're going to go to the appropriate module. We're doing about 1 module a week, right? And you click the overview or the videos. Basically, typically you'll have they'll tell you what I'm doing next, and the next thing will be a playlist of videos. Now, I know some of you may have had experience with flip lecture, and they're like, oh God, they're awful. They're like 4 hours of video lecturing, and the professor goes on. No. I worked really hard. This is like the 2nd iteration of these videos, and there will be a 3rd iteration of these videos eventually. And not only that, I've totally rated the videos I did for the graduate version of this course and pulled them into here. So this first week, like this is maybe, I don't know, hour and a half. It's never going to be more than 2 hours a week of video lecturing, and they're broken up into small chunks, about 5 to 15 minutes apiece. Okay. This is what you're going to be doing as your homework. Okay. And in homework, you'll be working on your big weekly assignment. Sorry, in class, you're going to be working on your big weekly assignment every week. Okay. Now, why am I doing this madness? Okay. The first reason is because the lectures are recorded. You can watch it and rewatch the parts you don't understand. Perfectly easy to do. But also from a pedagogical point of view, from a teaching point of view, the typical lecture setup where I am just simply blabbing to you for an hour and 20 minutes and talking to you, and you have the opportunity to ask questions directly to me, that is the worst time for you to have access to me, because this is the introduction to the material. It's the first exposure. It is mentally the easiest because it is your first exposure. It is the initial exposure, the learning. Much more useful, and when you're working at home on homework, that is the least useful. That is when you want me the most, and you don't have access to me. So that is not useful. So the flipped basically says, hey, we'll have easy access to the professor when we're working on our homework, and less access when we are watching the videos. That is kind of the point of view. The idea here is that a lot of work can be done in class. Okay, so each week, again, you'll just simply be watching these. Now, fortunately for you, because you might be feeling, oh God, I'm already behind, this first week is review. So if you're feeling very comfortable about the object-oriented stuff, all this is going over is objects and classes again, inheritance again, polymorphism. And if you haven't seen instance of or the for each loop, those might be worth taking a look at. But otherwise, this is review. And the assignment for this week is review with regards to that. And as asked, I always have recorded my lectures, always, and I will always make them available. Simply put, just go over here to home, click this friendly button over here. If you ever can't find it, send me an email and I'll direct you to it. Lecture recordings. I have not updated this because we do not have any lectures yet, but here is what it looked like last semester, the current semesters, and all the last times I did this course during COVID. So I will just simply move this line up here and put in a new playlist. And so if you ever miss class or oversleep or whatever, well, first off, if you oversleep past this class, that's very impressive. But if you ever miss it for some reason, you can find the lecture recording there. Okay, your labs are on different times, so be aware of that. If people talk about labs, right? Half the students will be in lab at 9 a.m. and half the students will be in lab at 3 p.m. Your TAs, though, will be the same. Jovan and Bill, they are awesome. They have been TAs for this class before, and they are great. They are both graduate students here. I will send out directions, by the way, later on the lab for tomorrow, because this week's lab is a bit up in the air because Jovan is flying back from out of the country. So I will be assisting with running the labs. Prerequisites. You need a C in Math Concepts 1 and in object-oriented programming. And just kind of an aside, you don't necessarily, we give you plenty of math. You don't necessarily need to be math to be a good programmer or even a great programmer, but you need math to be an amazing programmer or a wizard of some programmer of some kind. So if you're not great at math, don't let that deject you. It's a language, and learning a language can be hard, especially if you've been told time and time again that you're not good at it. Even if you've been told by nobody but yourself. Math is a skill, you got to work at it. But the correlation, the overlap there for math and computer science is abstract thinking. Okay. So if you've only got a C in 1068, think about why that was, and ask yourself if you're ready. Okay. And feel free to ask me. No judgment here. Total full disclosure for me, I was a terrible student during my freshman and sophomore years. I was like a CB student, nice, a couple of D's too, so for my freshman and sophomore year. So totally understand being unprepared for stuff. Okay. Technology, have a reliable laptop. If you don't have a reliable laptop, let me know so I can help you. Okay. Let's see. Textbook, recommended, not required. Okay. If the slides for the textbook can be found here on our page, you just simply go here to files, and boom, there's an entire folder called slides, which has the slides for this for this class, for that textbook. I am currently in the process of writing a textbook, open source, going to be, freely available online and produced at print at cost. That is the goal for the textbook, for this class. So that's currently in the works. But for right now, textbook is only a recommended resource. It is a good textbook. Don't get me wrong. It's written by 2 former professors here. But I also understand how much we all hate the textbook game right now. So office hours. Office hours are by are basically, we have basically set appointment hours, and then you can also email me for times outside those normal meetings. I still have to choose my office hours because everything's in flux right now. And it might change later in this, after the first 2 weeks. But for right now, once you see my hours, you just click, you can either click here to get to my office hours reservation page. Okay. And this is for the scheduled office hours. If none of these times work, send me an email. Okay. Or I've also got the same page embedded here. What you do is you just simply scroll down, simply click on 2168 so that the appropriate TAs will populate, and you can select the appropriate person you want to meet with and the time. Again, I have to plug in my office hours. If you need to meet with me, send me an email for right now, because I'm still trying to figure out what I want my office hours to be. Yes. I don't know if I'm hearing you. Are you speaking? Genevieve. I see you have your hand raised. Oh, okay. Also, you can drop things in chat as well, or DM me if you need to. No, I cannot hear you. Make sure. So I didn't even see there was an indicator for speaking. So let's
check your microphone input. You might not actually be going through Zoom.
Okay.
I mean, Genevieve.
Mm-hmm. All right, attendance. Basically, once we're back in the assumption is you're going to show up. If you don't show up, I'll assume there was a reason for it. Please let me know why why you didn't show up, and just be sure to, just keep me in the loop. And catch up on the lectures when they're posted. If you're sick, definitely don't come to class. Yes, Genevieve.
Sorry about that earlier. Can you hear me now?
Yes, I can.
Okay, so I missed the times there. For the appointment booking, is that required for if it's a listed available time, or is it just strictly for extra?
This is so these are a bunch of times that we already have allotted. It will create an automatic event in our calendar and also in your calendar.
Should we still email for
times outside these? Yes.
Okay, thank you.
Yeah, these are just simply our set office hours, our scheduled office hours that we are required to have by the school. And simply put, we found that booking office hours like this has been a very useful way of doing that. Okay, I plan on holding around somewhere between 4 and 6 a week, plus anything and plus appointments. Yes.
So do we have to can we schedule with either TA?
Yes, you can.
Okay. All right. Thank you. Even if it's not our TA?
That's correct.
Thank you.
Good questions. Okay. All right. So let's go and just quickly move on. If you're sick, don't come to class. Just tell me you're sick. Even if it's an exam day, just email me. Tell me you're sick. Okay, don't come to class. I'd rather you not come and infect me or anyone else with anything. Okay. Mental health, right? It's not like we're living during like some extremely interesting times. Like there's no reason why you'd be stressed extraordinarily, right? In all seriousness, like if you are having difficulties in class, do not hesitate to reach out to me. If nothing else, I can be a pair of sympathetic ears and I can direct you to the appropriate people. The time to reach out, though, is when you are having those struggles and not like at the end of the semester, when there really can't be anything done. So, just please let me know. The sooner you let me know, the more help I can give. Okay. If you have a DRS accommodation, let me know through the DRS office. If you need an accommodation and haven't gotten that yet, I can at least direct you how to get there. Speaking of DRS, we also have there's also been we're also looking for a volunteer note taker. Simply send me an email if you want to volunteer to take notes for somebody via DRS. I will be recording all the lectures as you've seen. If you are making your own recording, that's fine, but you have to let me know because Pennsylvania is a 2-consent state for recording. Grading. So the curve, the way it works is basically that your points are not curved, but the range of grades are. So for instance, 90 and above will always be an A. And what I do is I move the A- grade, the A- and the B- to bump people up accordingly. So for instance, 90 and above was an A last year. And I think like 88.5 and above were A-. That said, last semester, like I gave out a ridiculous number of A's, or I should say students earned a ridiculous number of A's. We had very few B's or C's in the class last semester. Very, like more than half the class got A's. And there was no curve needed on my part. I either was doing something extremely right or extremely wrong. So I will not give out extra assignments like to you specifically, but there will be extra assignments given out periodically for people to try and get some extra credit on. So your grades are based off of quizzes, 5%, 35% on labs and assignments, 35% on the exams, and 25% on the finals. I'll go into each of those categories. So quizzes, you find those here under under each of the modules. You'll have a quiz. If you'll give me a second. I generally allow, okay, it's in an external tool, but typically I allow multiple attempts on my quizzes. So that you can, because these are more like, are you keeping pace with the course? And are you keeping up with the readings and stuff? I'll be adjusting these due dates, by the way, because they were automatically imported from last semester. So if you feel like something's coming up a bit too soon, email me, and I might not, because I might not have gotten to it yet. Okay. But these are quizzes. They are untimed, unproctored. Just do them. And just see, and if they're to see, okay, what do I need to study a bit more so that I can retry it and get a better grade? Make sense? Labs and assignments are equal to your exams. Labs and assignments, they are the same thing. They are worth 35% of the grades. They are the big assignment that we do each week. If you are coming from 1051 with me, you'll remember that you had a lot of assignments via Runestone and then a weekly assignment. We just focus on the big weekly assignment in this class. So each week you will have a big weekly assignment. Sometimes you get your choice of two, like you do one of, but that is what we are working on. These assignments are demoed assignments, meaning that you have to, there's a 2-part process for turning it in. Submit it online, so there's a paper trail. So you do it, you submit it just like anything else you would on Canvas. But then you have to demo it to me or the TA. That involves showing that the program works, explaining pieces of your source code, and answering some questions such as like, okay, can you think of a different way to solve this? Or what if I change this variable? How does this affect your program? Those kind of things. Yes.
After we potentially move back to in-person classes, are we still going to be able to do the demos on Zoom?
Yes.
Okay.
Yes. All my office hours, I plan on being via Zoom. And then I plan on, and then any student who wants to meet with me at a non-traditional hour, it would be Zoom. Demos can be done. So you've got a lot of flexibility as to when to do with the demos. You can do it during the lecture. You can do it during the lab, because again, lecture, you're going to be working on the assignment. So if you're done with it, you can show it to me. Same with the lab. You can demo during the lab. You can also demo during office hours with me or the TAs. And you can demo to me or the TAs, and it can be to any TA. Okay, so hopefully that covered all the bases there. Okay. I will go into the late policy for these lab assignments. You turn them in it's 5 points off every day it's late. It's a pretty light penalty. The reason for this is that I'd rather you get it done than not do it at all, because the only way you get better at programming is by practicing. But sometimes you just don't plan accordingly and things take longer. Hence that penalty. The maximum penalty is half off, right? So not too bad. So they are determined late by when you turn it in, not when you demo it. So you can turn it in, demo it a week later, still get full credit for it. Okay. But the sooner you demo it, there might be a mistake, the sooner you can make a correction. If it's a quick correction that doesn't take you any time, then you can pretty much demo it and it's not going to be anything late. But if you like completely mangled part of the assignment, that might require the late penalty. So demo it sooner rather than later. This clause this is a clause I exempt a lot, but it's here to help me for the end of the semester. You have up to 2 weeks after the due date to demo your lab. So due date happens, you have 2 weeks. Otherwise, it becomes a 0. In general, we're lenient about that, but the reason we have that is because I would have students say, oh, I didn't know we had to demo our assignments. Well, I guess I'll demo them all now. And that was a painful experience for everybody involved, because generally there would be a lot of stuff that was uncaught because they never came to class. They didn't catch it, there were mistakes, and they would get 0s. So it was painful and time consuming and just not fun. So in general, if you need more time because you, for some reason, just let me know if you need more time to work on the assignment or more time to get the demo to us, right? It's just this clause in here is to prevent people from just dropping off the face of the earth and then coming in at the end of the semester. Okay. Yes.
This is going to be a Java class, correct?
Up until the end, yes.
All right, cool.
Once we reach the last three assignments, you are allowed to do in any programming language.
Awesome, thank you.
Okay. So now exams and finals, which are pretty much the same thing. This is a traditional kind of class where we do heavily weight the exams. Exams, the restrictions and the like on the exam, that depends on whether we are fully online or in person, but regardless, they will be electronic, they will be done on Canvas, and they will be done during your lab period. Okay. Now, they'll be electronic, so they'll be on Canvas. Last semester, when we were in person for this, the restriction on the exam was basically if it was on your computer, so like an IDE, that was fine. If it was any files that you had already downloaded onto your computer, that was fine. Any of the files you already had on your computer, great. If it was on Canvas, or you could reach it from Canvas, also great, you could use those. If it was on your personal cloud, also great, you could use those. But you couldn't just like go and browse the internet. That was the restriction. So if it was already, so basically anything that you had prepared in advance, you could bring in. You want to go ahead and download like half of Stack Overflow to your computer and bring it? Totally cool. But so basically, so it's essentially open electronic notes, if you understand what I'm saying, right? That was if we're in person, and that is the assumption. That might change and might become more open if we do this online, if fully online. But regardless, it is the reason for this is that we have gotten beyond the point of just asking, what does this code do? And instead, I need you to answer theoretical questions, and I need you to answer, write some programs. Exams will be proctored in the lab is the idea here. And they do have a late policy of their own. They are a tenth of a point every minute they are late. So you turn it in 2 minutes late. You got 100 on it, but you turned it in 2 minutes late. You didn't get a 0, you got a 99.8. 10 minutes late, you lose a point. An hour late, you lose 6 points. Okay. So you can turn in an hour late, still get an A, totally. Now this is just simply so that you stop panicking about the time limit, but also allows me to balance, not give people unlimited time to work on the exam, but at the same time, yeah, this is pretty reasonable, I think, like more than reasonable. You can take the amount of time you need. And yes, eventually, like if you turn it in 16 hours late, you will lose all your credit. So yeah, the idea here is that, I don't want you to stress out about the time. Okay. And if you need to resume it for some reason, then we can do that. But part of the big thing about that people panic about with exams is the time crunch. And I don't want you to, at least I can remove that panic. Okay. If you have an accommodation via DRS, ignore everything I just said. And because we will figure that out for you individually, which will probably be more permissive. But these, now, how difficult are the exams? It depends. Yes, Genevieve? Yeah.
So something I had a problem with last semester for my Java course was I wasn't allowed to use any environments in an exam setting, so I couldn't really verify that anything was working. Are we going to be able to use an environment?
Yes, that is my preference for this.
Okay,
class.
cool. Thank
Now
you.
that said, using that does come with a disadvantage where it is more time consuming to try to verify these things, but you can verify and test your code. But a lot of times it's up to you to basically make the framework for yourself to verify it. Yes.
So last semester for the open-ended coding questions, we were using like a text box, and it was, you can't use the tab key in Canvas. Will we be doing that as well?
You will be answering via so I will discuss this in more detail, but again, you're going to be able to use your IDE, so you can just copy paste your code.
Okay, great. Thank you.
Yep. I'll go into more details about this into Canvas, but the idea here is that you are using your tool. You have your tools. Okay. When the freshman class finally meets in person, that's when I like to do a lot of stuff on paper. You can use any tool you want. Any program on your computer is good. Okay. So there will be two midterms. The first exam will be around week 6. This is week 1. It is considered to be a bit tougher because of the abstraction. And of course, you don't necessarily know what to expect, but you will get a practice exam at least 1 week in advance. The second exam is consistently been a very high scoring exam. The average is typically around 87% for the second exam. And the students who do not do well on that are the students who do not study or who have not kept up with the material. Okay, which, as you can tell by the average, isn't too bad. And the final exam is cumulative, and that just really depends. The performance on the final exam, oddly enough, depends on when the final exam is scheduled for. If it's scheduled early enough, and if it's like the earlier it's scheduled in the final season, the better people do on it. Just because it depends on how burnt out you are. And there's unfortunately no way for me to figure out a way to counter that. Okay. The quizzes are not proctored. They are self quizzes. The exams are proctored. If they're online, I'm going to figure out how to do that. I dislike Proctorio, but this brings us perfectly into the next section, which is academic dishonesty, and I am very good at detecting academic dishonesty. I would like to remind every person in this class that pattern recognition is a subdomain of computer science, and plagiarism detection programs are written using computer science algorithms. In fact, one of the suggested assignments for CS1, and CS2 is write a plagiarism detector. So yeah, it's not super trivial to write that kind of program, but it's totally reasonable as an assignment. my current count from my last semester, sorry, last year's count of students who I charged with academic dishonesty was 47 students, and I had about 200 students a semester. So that's a lot of students overall. And the vast and pretty much and every single person I charged, it was because they went to Chegg. Do not go to Chegg. Chegg is just what you want to do if you want to fail the course, because not only are the answers easily to detect, they're also wrong. So just keep that in mind. Chegg is not good as a source. Okay. If you are having trouble, your first instinct should not be to cheat. Instead, your first instinct should be send an email to me asking help, help, help. I will get tickled if that is the actual subject line, but send me an email and I will walk you through. I will take your hand and I will walk you to the path so you can get yourself to that solution. Okay. I need to lead you to the answer and point you in that direction so you can get there yourself. There is no just hopping on a bus and getting to the answer automatically. However, that said, I'm trying to be reasonable here. I don't mean that to scare you. This is more to scare my students who are in CS 1051, because I've had more issues with them. I think of the students that I charged, only like 5 or 6 came from 2168. So the majority are freshmen. In fact, I do want you to work with each other. I firmly believe that the best way to master your material is to teach it to other people. There is a fine line between getting help from another student, and you can read through these all yourself, but I'm going to hit a couple important points as to what I consider reasonable and not reasonable. In general, saying my code doesn't work. Here's my code. Why doesn't it work? That is totally reasonable. You can share your code all you want. If you are the person who says my code doesn't work, I need help. But however, if your code is the one that's working, don't share your code. Make sense? So what is reasonable? Communicating, asking about the assignments or the material. Awesome, please do that. In fact, I have a Discord. I have a Discord set up for this class. Go to the front page and go right here. Here's a Discord. For those of you who don't use Discord, it's just a giant chat room I have set up for the class. It's got people who've taken this class in the past. So there's the invite. Feel free to join. I'm not on there now because I turned it off during class, but I'll be right back on. It's on my phone. I can answer questions quickly. Other students will be happy to answer questions quickly there too. But so please feel free to communicate with other people. Okay. Helping somebody identify a bug in their code. And that is, they sent you their code, you're viewing it online, whatever. As long as you're helping somebody else try to fix their code, great. Sending or showing your code to somebody you've written, possibly your classmates, so they can fix that code, great. Please, please, please cite that help, just so that if I see a similarity between two like chunks of code, I know where it came from. Make sense? Right? So if you show your code to Alice, Alice helps you fix your code. Just put in the comment, Alice helps with this part. It helps so much. Similarly, you're like, okay, is there a way to sort an array in one line in Java? Stack Overflow. Actually, let's do that now. Sort array Java. Right? Okay, sort an array in Java. Okay. Answers is how to do that. Arrays.sort. Okay, I'll just put that in, copy, put this in the comment, put that link in the comments. Congratulations, you've cited it. Make sense on how that works? And note that it wasn't like the whole problem. Like sorting an array, that's just simply a sub problem of some stuff, right? Perfectly acceptable to do that. Okay. Yes.
Do we have to cite for if we look up Like for that example there, it was kind of like one key word.
I
We
mean,
still have to cite for those.
it's good practice.
Okay.
It's good practice to do so. Typically, you're going to be citing something a bit more. If you cite something online, it'll be typically a couple more lines. And if it's built like here, you were getting something built into Java. But if it's like something that like this, where somebody wrote something, cite it. You know, like if you're using somebody else's function, it's generally good to make sure that you are not misrepresenting that you wrote that yourself. As long as you cite something, I will never be throwing you to the academic dishonesty kind of people. So here again, turning to the web elsewhere for solutions to technical difficulties, but not solutions to the problems. Whiteboarding, awesome. Working with a tutor or paying them. Yes, you'll be allowed to use notes during the exam. What is not reasonable? Going like, how do I find a solution? Like the first problem is Fox and Rabbit, looking up the solution to rabbit.java before you submit your own. Don't do that. I've seen the solutions. I know what the solutions are. I'll recognize them. Don't do that. Asking a classmate who's done their stuff to see it, or giving a classmate the solution when it's them and not you who is struggling to solve it, or paying somebody to work on it for you, or, getting Alice's stuff, changing a couple variables, and then turning it in. No. This is for the multi-part problems where I've got a bunch of individual problems. Those aren't too common, but like splitting, saying I'll do page 1, you'll do page 2. That's no, don't do that. Searching for or outright soliciting questions to exams or assignments, like looking up an answer or posting it, or posting a question on Chegg. If you find my answers, if you find my questions verbatim on a source like Chegg or online, ignore it. I've had students last semester in 1051 say that they just look at how other people do the problem to create their own solution. That's just cheating with extra steps. Another thing is finding code online that addresses the full question and then you don't cite it. It's finding code online you think might address the question and then blinding and copy and pasting it. That's not good either. You got to cite what you find. The most important thing is two things. If you're not sure, email me and I'll tell you. Okay. Second, if you know you violated the rules, you have 72 hours before to email me. If you email me that, there might be some internal sanctions, but I'm not going to forward it to student misconduct. After that point, I will. Okay. Because I will find it. I'm really good at it. See the Reddit posts. Okay. So that's not meant to scare you. I really want you guys to work together. In fact, the first assignment, you can work with somebody else and turn in identical code. And I'm recording that. You can cite me for saying that. Okay. Any questions about the way this class will be run? That was just more just making sure that you understood, hey, here's a list of things that are acceptable and not acceptable. Please work with people. Just don't like give them the answers that you're just robbing yourself of the opportunity to learn, because this is like a musical instrument, right? The only way you're going to get better at a musical instrument is by practicing it. Okay. Okay. I will give instructions, by the way, on how to join the labs tomorrow, especially since things are happening. So let's see. Yeah, you can work with somebody. Yeah, you can work with somebody all semester. The difference is that you just can't submit like identical code for stuff, except for a couple of accepted assignments. You can help each other when you're getting stuck. You can talk about, oh, I solved this, like for one of the assignments you'll do next week. You can go like, okay, how did you solve problem 5? Oh, I did it by going through the array and the array list in reverse. Oh, really? I did it by removing, every time I removed something, I went back to back. I went back a step or restarted the search. Oh yeah, totally. If you're working with somebody and you're worried about that, again, just simply say you worked with somebody. The openness goes a long way to making sure that everything's good. Okay. All right. So now a lot of you were with Professor demos. No, you meet up with me or the TA. We generally don't do recordings. Okay. So for this one, so okay, I know you were with Professor Fiore last semester, right? And I know that, and from the class, from what I heard last class, 11 o'clock, those of you who worked with Professor Fiore, you were using Mimir until it stopped, until it stopped working, and now you had to install either IntelliJ or Clips. So I have these videos right here under the modules, how to install Java IntelliJ in case you've forgotten or need to. This is a link. Now, this was made before 2021. I used adopt OpenJDK. Since then, they've moved to Adoptium. The URL still works. It will just simply tell you, hey, click on this button to get Adoptium, which is based off of Clips, I believe. So, and that's just simply a open source version of Java. You can use oracles. Their usage is just kind of mess. So if you want to sell something, you do not need IntelliJ if you use Eclipse. I just find IntelliJ to be far superior to Eclipse. You can use any tool you use. I currently use IntelliJ, but Eclipse, NetBeans, also good. You can use Visual Studio Code. That is one of the best programs that Microsoft has written in a while. And anything that Microsoft does that is open source recently, like since Windows 10, anything they've done open source has been rock solid and awesome. Okay. Like Visual Studio Code, Windows Terminal, the Edge browser, they've all been great. Normally I'm a big guy for open source. Normally, until recently I was a Linux user, but I can't run my music software and I can't run VR on Linux. So, those things are tough. So, but yeah, you can use whatever you want. You can use Vim and Emacs. Why do I think IntelliJ is far superior to Eclipse? Well, let me show you. And the reason being in Eclipse, and I need to stop sharing my screen, it's because of the keyboard shortcuts, to be honest. Share screen. So this will be the assignment. I'll go over this in a second, but for me to just simply do, I can create a for loop in IntelliJ just simply by typing for I, hitting tab. Or I can do a system out print line by hitting SOUT and hitting a tab. So I work a lot quicker. That's what it comes down to. Also, I find the UI to be a lot cleaner. That's it. So let's talk about the first assignment, okay? And hopefully by the there should be enough time to make sure that you're up and running. So here's what we're going to do. Let's go ahead and take a look at our first assignment, because most of the time won't be me droning on for 45 minutes now. Most of the time, it's going to be me talking for maybe 5-10 minutes, maybe occasionally coding doing some live coding, and then we work on the assignment. So let's go over here into modules. You can also find it under assignments and click on the Fox and Rabbit assignment. I will most likely alter the due date, but there's going to be two things: the PDF, which will cover what I'm talking about now, and this zip file, which I've already downloaded into my downloads folder and extracted it. Be sure to extract it, right? Download it and extract it. It's going to be in a folder called Hunt. And let me go ahead and actually start a new project. Actually, hold on. What can you see? You can't see anything. Why am I being dumb, right? Because I'm not sharing my screen. Let me go ahead and share screen. All that stuff. No, I did it so well last time around. So let's go over here. So go to modules. right? So you can find your Fox and Rabbit code, your first assignment, by going to modules or by going to assignments, right? Don't need any of this, right? And over here, Fox and Rabbit or modules, right? There's going to be a PDF, which is written instructions about all the stuff I'm doing right now, as well as this zip file. Hit the download button to download the zip file. I've already done so. It's here in my downloads folder. I'm going to go ahead and extract it. Be sure to extract it. It just makes the job easier. And there will be, as you can see, 9 Java files. Super intimidating, I know. Don't worry about it. So once you've extracted it, right? And what you're going to want to do is you're going to want to create a new project. This is very important, either IntelliJ or Eclipse. You'll want to create a new project. Okay. It's just easier if you do all your assignments as kind of their own individual project. You can put those projects where you need to, but easier to do this way. This is my version of the JDK I'm using. Next. This will create an empty project, and I'm going to call this Rabbit Hunt Afternoon, just so that we have a blank project. Going to open up in this window. This is what it should look like when you create a blank project. You'll have, also when you were creating a project, right? Let me quit out of Steam. Right over here in this folder, you have, so you should get this, what it looks like. Eclipse, I've seen some people have some issues with that. Don't worry, I know exactly how to fix it if you've got an error in Eclipse, but you want to see this. So what you do is you take all these files, works the same on Mac, just drag them over here to the SRC folder, the source folder. The source folder is where all the Java files for that project are going to live. Hit refactor, because that will fix it to make sure that's running. And now you'll see I have 9 files, 2 of which it's hard to see, but they'll have run buttons next to them. To confirm that they're working, you either select run like you would if you're in Eclipse on the files that have a main in them, which will be either Rabbit Hunt or greater, or click the arrow. And now what you should see when you run it is a graphical program, which doesn't look very blank, but that's okay. That's just how it works. And hitting run will do this. This is where I want you to get to by the end of, by the time you leave. So let me talk about that for a bit. Okay, so what is this assignment? This assignment is Rabbit Hunt. Your grade is out of 120 points. You get 20 points this time as a freebie just for demoing. The other 100 points are dependent on your survival rate. So there are 2 entities in this program: the rabbit and the fox. Okay. The red dot represents the fox, the brown, the rabbit. Okay. And the goal of the rabbit is to survive for 100 turns. The goal of the fox is to eat the rabbit and have a very yummy rabbit stew lunch thingy. So I'm going to increase this. You can see up here the turn counter. And now the game ends. The fox eats the rabbit after 70 turns. The board is random. You'll see that it is occupied by bushes, and then there's randomly generated bushes. These bushes block movement and line of sight. And this is a walled off area. This isn't Pac-Man where you can go off the edge of the map and come back around stuff. This is a static board. So there we go. And that's time the rabbit didn't last too long. Okay. So what is your goal? Your goal is to modify the rabbit's code so it doesn't die such a horrible death all the time. Because as you can see, when we run greater, it runs this game a bunch of times, 300 times to be precise. And you can see it survived 2 times out of 300, which is effectively 0%. So you get a 0. What you can do, so the first place, you you can only make 2 changes to the code, by the way. The first is you can increase the number of trials. Why? So just to ensure that you're not getting unlucky. Here, I'm increasing it to by 100-fold. Here, I've escaped 241 times out of 300, which is 0%. Your grade on this, these 100 points are graded on a square root curve, meaning that if you get an 81% survival rate, you will get a 90. This is calculated by taking the square root of your survival rate, multiplying by 10. 64% survival rate is an 80. 81% survival rate is a 90. So it quickly gives you a good score, but has very strong diminishing returns. Okay. Now, there are some ways to get 100, but it is very rare. If you are able to get a 90% survival rate, you're probably I would suggest stopping at that point. It's hard. You can get a pretty high survival rate based off of certain moves with just a few moves. Okay. There's a lot of files. So that is the first and only thing outside of the other file you can modify. The other file you can modify is the rabbit file, which is just right now this, just 12 lines of code, and most of them, and half of them are empty. And this is how it decides its move. Right now, it's deciding the move in a completely random direction, which explains why it's not living very long, right? You know, the rabbit's just moving randomly. See, it's just essentially flipping a 8-sided coin as to where it's moving. The fox, on the other hand, it's a sophisticated killer. It has an idea of what it's doing. But the only code you're allowed to modify is rabbit and this one line over here of greater. Fox has, as you can see, that's a lot to do. So why is this the review thing? Well, because it reinforces the idea of polymorphism, and inheritance. Both the rabbit and the fox are animals. An animal has all these methods. It has a private view of the model. I'll get to that in a second. And they can do things like look in a direction to see what's in that direction. You can look at a distance, as you can look in a direction and see how far you are from the closest thing in that direction. You can ask, can I move in this direction? And then you can decide what your move is, which is how you move. You just say, do you move by deciding what your move is and returning a number that corresponds to that move? Okay. Here, we're just returning a number and getting back up, and it's pretty much random. Notice that it's returning model dot something. So let's go ahead and kind of go through and close the things. We don't need greater anymore, really, so we can ignore that. Model, view, and controller. This is a very standard-wise way of doing a very standard model of doing graphic programming over here, where you have model, which represents the internal model. Okay. It represents the internal logical model. When we run greater, it's only really speaking to the model. The controller and the view, those are our graphics. A view helps us graphically represent what the model is. And the controller is basically all this stuff on the bottom, allowing us to control the program, hitting stop, hitting step. What is this? This is the visual representation of the look function right here, which I'll get into. So model, view, controller. So we don't really need to worry about view and controller because that's just showing us what we're seeing. So don't worry about this too much. Bushes, they just exist. They're just there. Close that. Rabbit hunt, we call that just sets up the model, view, and controller for us to work with. Okay, so really we've got we've gone down to caring about 9 Java files to 4 of them. Okay, so the model has some useful things. So, and we've seen animal. Rabbit and fox are animals, so they can do everything those can do. So model has some really cool things in there. First off, we're all the directions are numbers, but it's hard to remember which is which. So simply put, I will go model dot N to go north, right? Instead of doing 0, because that's hard to remember that 0 is north. And that 5 is southwest. Right. So those things are hard. Min direction is 0. Max direction is northwest. And then we have 8 for staying right put. You have numbers to represent the whether we're seeing an edge, a fox, a rabbit, or a bush, but so let's take a look at the fox code to maybe see and understand. Now, one of your instincts might be to copy the fox code in and try to reverse engineer it. Not necessarily a great strategy, because the fox is way more complicated than you need to be. The rabbit's prey doesn't really need a complicated strategy. The fox needs a complicated strategy. But it gives you an idea of how he works. So the first thing he does is that he's asked, okay, I say, I can't see the rabbit right now. Let me go ahead and look. Yep, you can make the rabbit look. It's an animal. Animals can look. Anything that an animal can do, a rabbit can do. Well, fortunately, the fox and the rabbit are fully capable of stuff. But so what he does, so here, what we've got here is that for all the directions, model.min direction, model.max direction, and a minor thing, the font I use here, I work with font ligatures. I love working with font ligatures. People sometimes hate it. So less than or equal to, when they're next to each other, the way it works is that it's basically just abusing features of the font so that the text renders it like this. This is still 2 characters, by the way. I just find that to be much easier to read. Similarly, the double equals become a fat equals and not equals becomes that. I find that to be much easier to read. Some people hate it, but it's my computer, so you can deal with it. All right. So basically it says, let me, for all the directions, let me look in that direction. If I'm looking at the direction and see a rabbit, I'm going to mark down that I've seen it and the direction to it and get the distance to it. And then what I do is that, hey, if I can, I move towards it if I can, or if I've seen them last. There's other stuff that I'll go over at a different time. But one of the key things here is this statement over here. If I can move in a direction, if I can move model.turn, you'll want to look up what model.turn does, or I will explain it in a bit, but that is one thing you want to become familiar with. It is the thing that makes you from going, it's the thing that prevents you from having to go, okay, if he's to the north, I have to go southeast. If he's to the west, I have to go, wait, if he's to the north, I have to go south, then I don't have to go northeast. Okay, or something like that. It prevents having to do all that math. Okay, so model.stay, if you're not using it, you're going to be in for a world of 8 times more writing than you have to. Okay. So let's talk about strategy before I get you to try getting this on your computers. Okay, so run. So if I stop this and do step, you'll see that he's calling step on each direction, and notice that it's line of that the bush blocks line of sight. Here, I'll run it again, see how it will stop at the bush. And they take turns, not at the same time, but one after another. So when this fox is looking, all right, he's looking in straight lines. Right? Mad MS Paint skills right here, right? Okay. So MS Paint. So now if we look at this, it turns out that means that over here, that we've got giant blind spots. This isn't normal vision. This is vision on a grid. It's moving like a queen, right? The queen being the chess piece here. So we've got it's got these massive blind spots where it can't see anything because it's only looking in straight lines. So the rabbit has two survival strategies. Exploit the blind spot. That is number one, because what you could do is that you can make the default behavior of the rabbit to be stay still. Okay. The default behavior of the rabbit is stay still. And if I see the fox, well, if I'm staying still, the only way I can see the fox is that if the fox is moved into line of vision with me. And because the fox has to look before it moves. So it looks, doesn't see me, it moves. Now it's my turn. I see it, but it hasn't seen me yet. So I can move into a blind spot. And that is survival strategy number one. Okay. Survival strategy number two, to use a term from the MMORPGs, is to kite the fox. For those of you unfamiliar with MMORPGs, one strategy is just simply get one player to annoy the monster and get aggro from the monster and have it chase you, while the other players whittle it down with damage over time effects. So in this case, well, you and the fox are going at the same speed. So if it sees you, I mean, if you program it right, you should just be able to get it to chase you. Maybe get it in an infinite loop of some kind. And infinite here is only need to be 100 turns. So what does that look like in this case? Well, for the original strategy, which I find the first strategy, which I find to be easier, what you might want to do is something like this, right? Which is model.stay is our default action, stay still. Otherwise, and how do I get this guy to look? For I in model.min direction less than or equal to, because we want to include the maximum direction. It's not like I've done this exercise a lot or anything. That's why I'm able to kind of just type at it so naturally. Part of this is just kind of immersing yourself in the language. You can say if look in the direction I. So go through all the directions. If I see the fox, if I see a fox, even though there's only one, then do something, move in the direction. Otherwise, stay put. That is the entirety of the code of the strategy number one. It's figuring out what moves to do and what order to do them that you want to try. That makes it interesting. Okay. Strategy two is basically get into a position, get the fox to say, there's a rabbit, I'm going to chase it, and then let it chase you in an infinite loop of some kind. All right. So we're going to be working on this in person, in lab on Tuesday, and we're going to work on it more, and we're going to work on it in lecture. Can you give the rabbit wings? So excellent question. I'm going to stand by and I'm going to stand by the rules as what you're allowed to modify. You are only allowed to modify the single line in the grader to change how many runs you're doing. And then you are only allowed to modify rabbit.java. So long as you comply with the rules. Then you're good. All right. So for the remaining 15-20 minutes of the class, please try to get you are free to go if you are able to get this set up, or if you want to go. Otherwise, get it set up. I'll be more than happy to, if you encounter any issues with the setup, let me enable screen sharing so that you will be able to share your screen and show me what's going on, because most of these things can be fixed in a minute with assistance. Okay. Otherwise, you're good to go.